Imagine looking at something with your own eyes and still being completely wrong about what you saw. What if I told you that your brain changes sounds, invents colors, hides objects, and even convinces you that a fake hand belongs to your body? The most surprising part is that these aren't mistakes caused by bad eyesight. They happen inside a perfectly healthy brain, and they affect everyone. As this video goes on, each illusion will reveal a different hidden shortcut your brain uses every single day. Some will seem impossible at first, while others might completely change the way you trust your own senses. By the end, you'll understand why seeing isn't always believing. Rubber hand illusion. A person places one real hand out of sight while looking at a fake rubber hand positioned in front of them. When both the hidden real hand and the rubber hand are gently stroked in the same way at the same time, the brain begins to treat the fake hand as part of the body. If the rubber hand is suddenly threatened, many people react with real fear or even pull away. This illusion shows that the brain does not simply know what belongs to the body. Instead, it constantly combines information from sight, touch, and position to build the feeling of ownership over our limbs. McGurk effect. Sometimes what we hear depends on what we see. If the sound of one syllable is played while the speaker's mouth forms a different one, the brain often creates a completely new sound that was never spoken. Many people are surprised when they close their eyes and suddenly hear the original audio correctly. First described by psychologists Harry McGurk and John MacDonald in the 1970s, this illusion reveals how closely hearing and vision work together during everyday conversation, especially in noisy places. Stroop effect. Reading words feels so automatic that it can interfere with other tasks. When the word blue is printed in red ink and someone is asked to say the color instead of reading the word, the answer usually takes longer. The brain briefly struggles because two different pieces of information compete for attention. This simple test has become one of the most famous experiments in psychology and is still used to study attention, self-control, and how people process information. Hollow face illusion. A hollow mask, viewed from the right angle, often appears to be a normal face sticking outward instead of curving inward. Even when people know they are looking at the inside of the mask, the illusion can remain surprisingly strong. Our brains have spent a lifetime learning that faces are almost always convex, so they favor that familiar interpretation over the actual shape. It is a clear example of how past experience can outweigh the evidence reaching our eyes. Color illusion. Colors do not exist as fixed properties in the world. They depend on light, surrounding colors, and the brain's interpretation of the scene. A gray square can seem lighter or darker simply because of the colors around it, even though its actual shade never changes. The visual system constantly adjusts for different lighting conditions so that objects appear stable throughout the day. While this usually helps us understand the world, it can also produce striking illusions. Checker shadow. A famous illusion created by vision scientist Edward Adelson shows a checkerboard with a shadow falling across it. Two squares that appear to be completely different shades are actually identical in color. The brain assumes that areas inside shadows should look darker, so it automatically corrects for the lighting and changes how the squares appear. Measuring the image or covering the surrounding pattern reveals that the colors really are the same, highlighting how strongly context shapes perception. Motion illusion. Some still images seem to ripple, rotate, or drift even though nothing is moving. Tiny differences in brightness, color, and repeating patterns encourage the eyes to make small natural movements called microsaccades. As the brain interprets these signals, the picture appears to come alive. Artists and scientists have explored these effects for decades, showing that motion is not always something our eyes detect directly but something our brains actively construct. Blind spot. Each eye has a small area where the optic nerve leaves the retina. Because there are no light-sensitive cells at that point, anything falling there cannot be seen. Under normal conditions, however, we never notice the missing patch. The brain quietly fills in the gap using information from the surrounding scene and from the other eye. This hidden process reminds us that vision is not a perfect recording of reality but a carefully completed picture. Cocktail party effect. In a crowded room filled with conversations, people can often focus on a single voice while ignoring dozens of others. At the same time, an important word, such as their own name, may instantly grab their attention from across the room. The brain continuously filters sounds, deciding which ones deserve attention and which can fade into the background. This ability makes everyday communication possible even in busy and noisy environments. Change blindness. Large changes can happen right in front of us without being noticed if they occur during a brief distraction, a blink, or a camera cut. A person might swap places with someone else or an object may disappear, yet observers often fail to spot the difference. The brain stores far less visual detail than people usually imagine and instead builds a useful summary of the scene. This illusion has important lessons for eyewitness testimony, driving, and everyday awareness, showing that seeing something does not always mean noticing it.